All right, class. So in today's lesson, we're going to be looking at the laws of exponents. More so, it's just the introduction about the laws. And with that introduction, we got some vocabulary, and we're going to go over each one of the laws to make sure that we have an example of what the problems will look like. Okay. So let's start with the vocabulary. First thing that we have is what we call a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. Okay. Monomials are single term. Monomial means one. Okay. Now, with that, we have the next definition, which is going to be exponents. Exponent shows repeated multiplication. So the little number that is attached to a big number, that is an exponent. That number tells us how many times we can multiply that big number to itself. Okay. And that leads us into the third definition or third vocabulary where exponents represent how many times a number, which is also called your base, is multiplied to itself. So looking at the example that we have, if you notice that inside that cloud we have 6 squared. Now with that 6 squared there are parts, like the entire 6 squared is called a power. And inside that we have two numbers, which is a 6, which is a big number. Okay. And we have a little 2. Now the big number is your base, and sometimes I will call it your big number. Okay. And then the little number is your exponent. All right, let's not forget that the exponent tells us how many times we can multiply that big number. Like for this one, it's really saying that we have 6 times 6. That's what that exponent tells us. It says we can multiply that 6 twice. All right. Now, the product of that is 36. So 6 squared will produce 36. And just like I said, this is called the product. It's the result that we get when we multiply it. All right, so now we have a clear understanding of the vocabulary. Let's look at our first key concept. In our first key concept, we're going to look at the very first law. Okay, in that law, it is called the product of powers. And the product of powers says that if multiplying two numbers with the same base, you're going to add the exponents. All right, so if we were to pick out some key things there, same base is important, and add. Same base means your big number has to be the same. Now, not every time in every one of these problems that we have for product of power will the big part be a number. It can also be a letter. Okay. But no matter what, they have to be the same. And then we're going to take the exponent, which is the little number, we're going to add it. All right. So now I'm just going to give you an example of what some of the problems will look like that is considered to be the product of powers. So the first one that you could possibly see and as an example will be like x squared times x to the third. That's one. Or you can see it as 2x to the fourth times 2 to the fifth. Or you can see it as 10x squared being multiplied to 3x to the fourth. These are all examples of what product of powers could look like. So if we needed to identify what law to use, and we look at these examples, something similar, meaning that we'll take the bases. And if you notice that all your bases for each one of these, for each problem that I wrote, has a base with a little number attached to it, is the same. And like in that last one, the 10 and the 3 are not the same, but those are not bases. The exponent that you see here is only attached to that x. Same thing with this 4 is only attached to that x. That is the base that has to be the same. Okay, so now let's look at the next law. All right, so for the next key concept in the next law, we're looking at the quotient of powers. And the quotient of powers it says if dividing, so quotient means dividing. If dividing two numbers with the same base, you're going to subtract your exponents. So quotient, as we said before, quotient means dividing. Same base is there again, and then this time, if the bases are the same, we're going to subtract. Okay, so if we focused on that, let's look at a couple examples of what we will have for it to be quotient of powers. So an example of quotient for of powers would be, let's say if we have r to the ninth power being divided by r to the fourth power. If you notice, it kind of looked like a fraction. Okay. Another example would be, let's say 4 to the 10th divided by 4 to the 6th power. And, a little bit harder problem will look similar to, let's say if we have s to the 7th, t to the ninth, and u to the third. All of that is being divided by s to the fourth, t to the seventh, and just u. All right. So what we're focusing on here in all of that is that we got a s, a t, and a u at the top. We got a s, a t, and a u at the bottom. That means same bases. Same for the other ones. There's a 4 as a base here. At the bottom, there's a 4 there. We have a r here as a base and an r here as a base at the bottom. So now whenever we see problems like this, the rule states that we'll take the little numbers, the exponents, and we'll subtract them. Okay? Now let's look at the next law. The next law is called your zero law or zero exponents. And it says that any non-zero number with an exponent of 0 is equivalent to 1. So equivalent means equal to. Okay? It's equal to 1. So to give you some examples of that, we could have, let's say, 3/4 raised to the power 0. Or we could see like y raised to 0. Or we can even have problems that looks like x to the fourth, parentheses raised to the power 0. So all of these right here are considered to be zero exponents examples. So if we see anything raised to the power of 0, so the little number is a 0, it is equivalent to 1. So the result of that will be just 1. All right, moving to the next law, which is negative exponents. And for negative exponents, it says for any non-zero number, like a, is raised to a negative exponent, place the power in the denominator, and rewrite the power with positive exponents. That's a mouthful. Okay. So really what that is saying is that whenever we have negative exponents, we have to make negative exponents positive. And the only way we're going to make negative exponents positive is that we're going to have to change the location. And what I mean by that is in a fraction, we have two parts. So in every fraction, you have a numerator and a denominator. If you get a problem and the exponent is negative in the numerator, which is at the top of the fraction, it's going to have to move to the bottom of the fraction to become positive. If you get an example that says that your negative number is at the bottom, which is called the denominator, you're going to have to take that denominator and move it to the top of the fraction to make it positive. Okay. So it's like switching locations. Now, to give you an example of what negative exponents will look like, we have one that's like g raised to the negative 4th power, or you will see 1 divided by h raised to the negative 7 power. You can even see 4 to the negative 3 power x squared. Or give you one more, be 1 divided by 2x to the negative 5 power. Now, looking at all of those examples, the negative 4 is attached to the g. The negative 7 is attached to the h. In this next example, we see that we got a negative 3, but it's only attached to that 4. It is not attached to the x squared. only to the 4. And it's the same thing similar to what you have in the last one. That -5, which is a negative, is only attached to that x. It has nothing to do with the 2. Okay? So you can only move what the negative exponent is attached to. All right? So let's keep moving through our laws. In our next law, we have what is called the power of a power. Now, in a power of a power, it says that if raising a power to a power, which is an exponent to an exponent, you're going to multiply those exponents. Okay? So if we're raising a power to a power, which is same thing as an exponent, you're going to multiply the exponents. All right? So now this one is only really focusing on a single base. We'll look at one with multiple bases in a second. So to give you an example of what we mean by power of a power, we could have in parentheses x squared raised to the fourth power. What you will notice in that is when we look at this one has an exponent already and it's raised to another exponent. That's what they mean by power to a power, exponent to exponent. All right. Another example will be 3 to the third. That will be in parentheses raised to the power of 6. Yet again, the 3 is an exponent and we have it raised to another exponent. That's how power over power looks. And then the last one, we have, let's say, x squared raised to the third power. These are all similar examples of what power over power will look like. Okay. Now, in the next law, we have power of a product. Now, power of a product is basically saying that we need to find the power of each factor in the parentheses and multiply it. So powers are exponents. Each factor in the parentheses is multiplied. Now this one deals with multiple bases. All right. So this one deals with multiple bases. And with this one, when power over power is like distributed property in a sense, but with exponents only. But to give you an example of what power over power is we have, let's say, x squared y to the fourth. All that is inside the parentheses raised to another exponent on the outside. That's where we get the power of a product. Power of a product means we're going to take the number on the outside, multiply it into every exponent that is in that parenthesis. Okay. They give you another example. We have 2x squared raised to the power of 4. And the last example for this one, we got, let's say, -4 x to the third raised to the power of 2. Okay. So all three of these are some examples of what power of a product could look like. All right. All right. So let's move to the next law. In our next law, which is also the last law, what we're dealing with in this one is called the power of a quotient. And we learned before that quotient is nothing but division. Okay. But what it states is that for any numbers, A and B, where B is not equal to 0, B is the number at the bottom of the fraction. It cannot be 0. Okay. If the quotient of A and B is raised to a power, you have to raise both the numerator and the denominator to the given power. Raise in this case is like multiplication. Okay. So it's really like taking whatever the exponent is on the outside of the parenthesis and you have to multiply it to each, which is the top and bottom numerator and denominator of that fraction. Okay. So to give you an example what it could possibly look like, let's say we have parentheses r over x. Now that is inside of parentheses, and we're going to raise that to, let's say, 2. What that's saying is I have to take this 2 and attach it to this r. I have to take that same 2 and attach it to that x. And that is all by multiplication. Okay? Now, to give you some more examples, in parentheses, we're going to have x squared over y to the third. You're going to raise that to the fourth power. And then another example, which will be our last example, is 2/3. All of that is raised to the second power. Now, what we're looking at are examples that allows us to identify what rule to use or what law to use in the situation. Okay. Now, all these examples that I gave you for each one of these laws, if I see something that looks similar to that, then that's the law that I need to use. Okay. So far, we're looking at power of a quotient, power of a product, power of a power, negative exponents, zero exponents. We have quotient of a powers, and we have product of powers. Now, all these laws are basically put in play to help simplify the steps that we would have to take in order to evaluate or simplify problems like these that you see as an example. Now, we haven't solved any of these problems, which will be in the next lesson. This is just an introduction to the actual laws that we're going to be using because we have to kind of remember these. Okay. Now, if you have any questions, don't hesitate to ask.